This is Honors Geometry Lesson 7.4, Special Right Triangles. So we're going to investigate two triangles we call special right triangles. And they're special because you're going to notice a pattern and we're going to be able to take shortcuts. Instead of using the Pythagorean theorem or other methods to find missing angles or sides, we're going to use these new shortcuts. So the first one, we're going to start with a square. And we know a square has four right angles. And it has four congruent sides. And when we draw in the diagonal, what it does is it cuts that 90-degree angle into two equal 45-degree angles. So what we have is what we call a 45-45-90 triangle. So let's investigate what the shortcut is. So let's just say the side lengths are 2 units. Using the Pythagorean theorem, we have 2 squared plus 2 squared equals c squared. We have 4 plus 4 equals c squared, 8 equals c squared. Let's simplify that radical. That's 2 times 4, 2 times 2. We have a pair of 2's, bring it out. We have a 2 left over, it goes inside. So we find the length of the diagonal, or the hypotenuse of our 45-45-90 triangle, is 2. Let's try it one more time. I'm sure you'll see the pattern forming. Let's say now that our sides are 3. And we're looking for the length of the diagonal. So again, we're going to use the Pythagorean theorem. 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. Square root both sides. We have 2 times 9, 3 times 3. We have a pair of 3's. We bring it out. We have a 2 left over, stays inside. So our length of our diagonal is 3 root 2. So I'm thinking right now you can probably see the shortcut. The length of the diagonal, or the hypotenuse of the 45-45-90 triangle, is the length of the side times the square root of 2. So without doing the math, if I told you the lengths of the last one are all 4, and I ask you what would be the length of the hypotenuse, or the diagonal, you could immediately tell me it's 4 root 2. And that's what it's telling us down here. A 45-45-90 triangle is an isosceles right triangle that can be formed by cutting a square in half, which is what we did. And the shortcut is that the hypotenuse is the square root of 2 times as long as each leg, and that's what we just discovered. All right, let's try some easy ones. The idea is that they're supposed to be easy. So you know it's a 45-45-90 triangle. They have a couple different ways they can tell you. They can tell you have a 90 and a 45, then you can automatically assume the other one's 45. So you know that the legs are the same. So if this is 5, we know this is 5. We know the hypotenuse is the length of the leg times the square root of 2. So if this one's 4, we know this one's 4. We know this is 4 root 2. Easy as that. If this is 10, we know this is 10. We know this is 10 root 2. If this is 2, this is 2. This is 2 root 2. And then if it's backwards, that's fine. If they tell you that the hypotenuse is 5 root 2, you know that means each of the legs are 5. And if the hypotenuse here is 4 root 2, you know that means each of the legs are 4. Easy peasy. But we know it's not going to stay that easy, right? Here come some tricky ones. All right, so here we go. We recognize we have a 45-45-90 triangle. The other ways you'll sometimes see it is what they'll do is they'll just slash that. If it's isosceles, you can assume it's a 45-45-90 triangle. In this case, they chose to mark the 45 for us. All right, so our legs, let's go ahead and just call it x, x, x root 2 is the shortcut for a 45-45-90. We expect to see a root 2 here, and kids would raise their hand and say, Mrs. Deason, you left the root 2 off. Nope. This time the length of the hypotenuse is 6. What are we supposed to do with that? We're just going to solve it algebraically. We say that x root 2 is equal to 6. Divide each side by the square root of 2 to get rid of that. So we now know that x is 6 over root 2. We learned we can't leave that radical in the denominator. That's a no-no in math. So what we do is called rationalizing the denominator. We're going to multiply it by itself. So we get 6 root 2 over the square root of 4, which is 6 root 2 over 2. And you can simplify that 2 goes in there 3 times, 2 goes in there 1. So we know that the length of the legs are both 3 root 2. And if we would test that, 3 root 2 times root 2 would give us 3 root 4, which would give us 3 times 2, or we'd be back to 6 that we started with. All right, what if they put a root 6 where we expect to see a root 2? That's all right, we can handle that. Again, the shortcut is x root 2, and our job is to figure out what the x is. So we're going to say x root 2 equals 2 root 6. Divide each side by root 2 to see what x is. And we're allowed to simplify that. That's why we studied that. 2 goes in there once, 2 goes in there 3 times. So we're left with 2 root 3. Square root of 1 is just 1. We don't need that anymore. So the answer to the question, what are the length of the legs? They're both 2 root 3. And if you want to check it, you can say, is 2 root 3 times root 2 root 6? Yes, it is. All right, here we go. One more. This time, we expect to see a whole number, and they gave us a fraction and a radical. Let's see how that goes. So again, the shortcut for the 45, 45, 90 triangle is x root 2. You can call it n root 2, whatever you want. So this time they told us that our leg is 3 root 2 over 2. So we know that this leg is also 3 root 2 over 2. And the tricky part, what's the hypotenuse? So we're going to take this, we're going to put it in for x, and we're going to multiply by root 2. No big deal. 2, oops, make that 3 root 2 over 2 times root 2 gives us 3 root 4 over 2, gives us 3 times 2 over 2. We can cancel those 2's out, so it looks like the length of our hypotenuse in this case is 3 units. All right, let's look at the next one. Second shortcut is called a 30, 60, 90 triangle. And the way you get that 30, 60, 90 is you take an equilateral triangle, equilateral, equiangular. So we know that we start with all 60-degree angles. Now we're going to drop that altitude, and it's going to split that bottom in half. And it's going to split that 60 into two 30s. So now we have two 30, 60, 90 triangles put together. All right, because it was equilateral, we know all the side lengths are the same. So let's just pick a number. Let's say the sides are 4. When we drop the altitude, it split that 4 into two 2's. Now let's just do Pythagorean theorem to find out what the length of that altitude is. So our 4 is our c, our hypotenuse. So we're going to say 2 squared plus b squared equals 4 squared. 4 plus b squared equals 16. Subtract 4 from each side. B squared equals 12. Let's square root both sides. Let's break that down. 2, 6, 2, 3. It looks like we have a pair of 2's that come out. 3's left inside. And again, you're probably going to see the shortcut real quick. Let's do it one more time. Let's make these sides 6. So I have 6, 6, 6. When I drop that altitude, it's going to split that 6 into two 3's. We know these are 60's. We know we split that 60 in half, made it two 30's. All right, so let's do Pythagorean theorem again. We have 3 squared plus b squared equals 6 squared. 9 plus b squared equals 36. Subtract 9 from each side. It looks like we're going to get 27. Let's square root that 27. 3 times 9, 3 times 3. Have a pair of 3's that comes out. 3's left over inside. And there you have it. So the secret for the 30, 60, 90 triangle is the side opposite the 30 is the short side. We call that the short leg. That's the half of what the hypotenuse is. Okay, so we'll call this x. The hypotenuse will be twice that big. We'll call that 2x. And then the side opposite the 30, we call that the long leg, is the short leg, which is 3, in this case x, times the square root of 3. And there you have it. That's the secret of the 30, 60, 90 triangle. So to put it into words, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. We saw that. And the longer leg is the square root of 3 times the shorter leg. All right, let's practice. Okay, and again, these are called shortcuts, so they're supposed to be easy. So I hope you find them easy. Okay, the first one, we're given the short leg. They only have to give you one of the 3 legs. We know it's a 90, we know it's a 30, that means this has to be our 60. They chose to give us the short leg, and to remind you of the shortcuts, the short leg is x, the hypotenuse is twice that big, or 2x, and the long leg across from the 60 is x root 3 this time. So they're telling us x equals 2. Nice. So we know that 2 times 2, that means our hypotenuse is going to be 4. And we're going to put a 2 in here for the x, so we know our long leg is 2 root 3, easy peasy, that easy. All right, here we go. This time they chose to tell us the hypotenuse is 10. The shortcuts again, across from the 30, I call x, across from the 90, our hypotenuse is 2x, and across from the 60 is x root 3. They have to tell us one of those 3 things. This time they chose to tell us that the hypotenuse is 10. So if 2x equals 10, we know x equals 5. So I go to where x is and I put a 5. I know my short leg. That's, remember, we dropped, if you sort of envision that whole equilateral triangle, when I dropped that altitude, it split that 10 into 2 5s. And then now across from the 60 is x root 3. We now said x is 5. So we know the long leg is 5 root 3. Easy peasy. All right, this time they chose to tell us that the long leg across from the 60 is 5 root 3. That means we know that this is 5 across from the 30. Across from the 90 is twice that big, or 10, and we're done. All right, we wish it would be always that easy, but it's not going to. Let's try some ugly ones. All right, here's our 30, 60, 90 triangle. And they have to give us one side. And this time they chose to tell us the side across from the 60. Wait a second, we expected to see a root 3 there. There's no root 3. That's okay, we can handle it. Let's go ahead and write down our shortcuts. X, 2x, x root 3. So this time they're telling us that x root 3 equals 12. So I'm going to write that down. Let's get rid of that root 3 and see what our x is. So our x is 12 over root 3. We know that's a no-no in math. We can't leave that radical there. So we're going to rationalize. That gives us 12 root 3 over root 9, which is 12 root 3 over 3. Let's simplify that fraction. You don't want to leave it that way. 3 goes in there once, 3 goes in there 4. So we can now see that the value of x is 4 root 3. And so let's go up here and say 4 root 3. And then our hypotenuse is twice that, 2 times 4 root 3. So we're going to make that 8. We know we can't multiply an outside by an inside. Don't be tempted to do that. So it's simply 8 root 3, and we're done. All right, here we go again. Here's our 30, 60, 90. This time, where we expected to see whole number, they put a radical. We can handle that. That's our 2x, this is our x, this is our x root 3, our shortcut that we just learned. Let's go ahead and get rid of this. There we go. All right, so they gave us the piece we needed. We need to know one side, so 2x equals 2 root 2. Divide each side by 2. It looks like x equals root 2. No problem with that. So we go to where we consider it our x, that's root 2. And we go where it's x root 3, so we say it's root 2, root 3. We know we're allowed to multiply those, so we get root 6, and we're done. And one last one. Here we go. Let's write our shortcuts. Here's our 30, 60, 90. This is x x root 3. This is 2x. And this time they told us that 2x equals 8 root 5. 2x equals 8 root 5. Divide each side by 2. It looks like x equals, let's simplify that, 4 root 5. Beautiful. All right, so we go to where we consider our x across from our 30. We call that 4 root 5. And then we go across from our 60. In place of that x, we now know x is 4 root 5. So we're going to say 4 root 5 times root 3. So that's going to give us 4 root